Okay, welcome to review of trigonometry. We're going to go over today everything we should know from grades 9 to 11. We have been doing trigonometry for ever and ever. So this is just a review of everything we should have covered up until now. And then tomorrow's lesson, we're going to start with some new material. So firstly, the unit circle. The unit circle is a circle centered at the origin of the graph with a radius of 1. That's why we call it the unit circle. It is 1 unit in terms of length or radius. We use the unit circle as our base for everything we do in trig. As I mentioned in class, everything in math, at least in terms of trigonometry, actually centers around a circle. So the center of the circle is the origin of our xy axis. So this point is 0, 0. We head off to the right, and this point here is 1, 0. This is 0, 1. This is negative 1, 0, and 0, negative 1. So when we're on the unit circle of radius 1, we can draw the radius at any point in the circle. The radius creates an angle with the x-axis, which we refer to typically as theta or some other Greek letters, but we'll use theta as the one most often. When looking at the length of the legs of the circle, so the shorter sides of the circle, we are going to use ratios to identify what those are. So the length of our radius is 1. When we are identifying the height and length of this triangle, the height is identified as sine of the angle. Remember, sine is opposite. Here it is, opposite over hypotenuse. Well, our hypotenuse is 1. So opposite over hypotenuse gives us the y value of our point here, x and y, right? This height is y from the x-axis, and this is x. So our sine of an angle represents the y value of any coordinate on the unit circle, and that leads us to the cosine being the x value of any point on the unit circle. So really, we could even rewrite this coordinate as cos theta sine theta, right? Because we're using triangles and circles to represent different values and different ratios of the triangle that it creates within the circle. Now, what about tangent? Tangent of the angle is opposite over adjacent. So x, whoopsie, pardon me, height y over x. In other words, sine theta over cos theta. Well, what does that actually represent in terms of the line that we drew in pink? This is representing the rise, and this is representing the run, also known as the slope. If we remember back to grade 9 when we did rise and run and analyzing two distances between 2 points. So the tangent of the angle represents the slope of the line between the origin and the point on the circle. Some other things we need to remember about some general circle information is the equation of a circle is given by radius squared is x squared plus y squared. And the equation of the unit circle, we know that the radius has a value of 1, so 1 equals x squared plus y squared. In the unit circle, it's also always important to remember that we start on the positive x-axis. This is our starting point. And when we move, we always move counterclockwise. I'm going to use CCW to mean counterclockwise. So we start at the positive x-axis, we move up and to the left around the circle. This is the general rule that we use when we work with trigonometry. Okay, so again, this is a basic review. If I have an angle in a triangle, let's say it is this corner, we label the side across the angle as the opposite side. We label the side touching the angle as the adjacent, and the longest side as the hypotenuse. When we are looking at the sine ratio, this is opposite over hypotenuse. The cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. So we talked a little bit about this on Friday. Okay, so remember the sine represents the vertical component, the cosine represents the horizontal component, and the tangent represents the slope of the angle in the triangle. A couple of other things you would have learned likely in pre-cal, I'm going to say 11, or maybe even pre-cal 10, depends who your teacher was and where you learned this. If we have a triangle that is not a right angle triangle, so a triangle like this, we label the angles of the three corners with capital letters, A, B, and C, and we label the sides of this angle with lowercase letters, and the letters match the angles across. So where letter A is across, this side would be called little a, this would be little b, and this would be little c. The other two laws I'm going to remind you of is the sine law. And the sine law states that the ratios sine of the angle A compared to its length is equal to the sine of angle B compared to its length, which is equal to the sine of angle C compared to its length. So this is true for angles of not right triangles. It does work with right triangles as well, but usually we have a simpler formula right here for right angle triangles. And we also have the cosine law. Cosine law states that the length of one of the sides, let's say c squared, is equal to a squared plus b squared plus 2 times a times c times the cosine of angle C. So again, remember that lowercase letters represent side lengths and capital letters represent angles in degrees. In this case, we're going to work with degrees for the next couple of days, and then we're going to switch over to radians. All right, so that's a bit of a review. The other thing I want to talk about is where on our unit circle are the three values, sine, cos, and tan, positive versus negative. Okay, so let's look here. In example 1 here, let's look at the sine of an angle. The sine represents the y value, meaning the height of our triangle. Where is the height positive? Well, it's positive above the x-axis, and it is negative below the x-axis. So depending where we draw our point, the y value will be positive in the top half and negative in the bottom half. When I look at cosine of an angle, this represents the x values. Where are the x values positive? Well, they're positive on the right side of the x-axis, and they're negative on the left side of the x-axis. And then lastly, we have tangent. Tangent is the ratio of y over x. So anytime the signs are the same, then tangent will be positive. So it's positive up here and it's positive down here, right? Because I have negative, negative. Negative divided by negative gives me positive, right? So tangent is positive in the upper right and lower left corners, and it is negative in the other two. A quick way to remember this is what we call the cast rule. If we start in the bottom right corner, cosine is the only thing positive in this quadrant. All of the ratios are positive in the first quadrant. Only sine is positive in the top left, and only tan is positive in the bottom. This is something I want you to know and memorize if you don't already know it. Okay, this is quadrant 1, this is quadrant 2, this is quadrant 3, quadrant 4. Notice I moved in counterclockwise direction as before. Okay, so cast, starting in the bottom right corner, this is where all of them are positive. All are positive in quadrant 1, and then the other 3, only one of them is positive. The other two things I want you to, again, memorize. You should know this. This will not be on a formula sheet. This will not be given to you because, again, this is review. There are two special triangles that we're going to memorize, which is going to help us tremendously in this unit. And this is the triangle that is a right triangle with angles of 45 degrees in both of the other corners. An angle that or a triangle that has 45 degrees in 2 out of the 3 corners means its side lengths, its legs, are both the value of 1, and the hypotenuse is root 2. This is always true. The other one is where we have, again, a 90-degree triangle where the small angle is 30 degrees and the large one is 60 degrees. And we have the hypotenuse is 2 and the short length is 1 and the longer leg is root 3. Now, again, root 3 is smaller than 2. Always remember that the hypotenuse is the longest length. So please don't put a root 3 there. I know 3 looks bigger than 2, but it's root 3. Okay, so these tell us some key features. And here, note that if I take the sine of one angle, it will match the cosine of the other angle. So sine 30 or cos 60, it doesn't matter. It's going to give us the same ratio. And this is true for all special triangles. Okay, so now if you are able to draw this kind of on the side of your paper, you should be able to find these ratios without the use of a calculator. And I want you to do this with me today, and I want you to find them in exact values. So I'm not interested in decimals, just write them as fractions. The cosine of 30, so I go to 30 degrees, which is right here. Adjacent is here, or hypotenuse is here. So this is just root 3 over 2, and I'm done. I don't have to worry about anything else. So cosine of 30 is root 3 over 2. Tan of 60, this is opposite over adjacent. Adjacent is 1, so I don't have to write the denominator there. Tan of 45, this is just going to give me 1 over 1, right? Sine of 45, this is going to give me 1 over root 2. And I'm going to make a little note here. We are always going to be rationalizing our denominators, meaning if you have a square root in the bottom, multiply by that bottom to get rid of the square root in the bottom. We don't like square roots in the denominators. It makes life a little bit complicated later on. So this will be root 2 over 2. This is how we're going to write the sine of 45. All right, sine of 30 opposite over hypotenuse. This is just going to give me, oops, wrong color here, 1 over 2. And cosine of 60, 1 over 2. Notice that these are the same, right? Sine of 30, cosine of 60. Because both of these angles are on the same special triangle, they are going to be equal to the same value. So why special triangles are really handy. Okay, so again, you should know how to draw the two special triangles and what lengths are on there. You should also know where sine, cos, and tan are positive. You should know these laws also by heart and how to set up a unit circle.